So far we have talked about the ideal structures such as the trigonal planar and how when you substitute a surrounding atom into a lone pair, you have a bent structure, such as this would be the typical case, and this is a bent structure. Or when you have the perfect tetrahedron and now you have some substitutions such as the trigonal pyramidal or another band. We said, well, the angles are gonna be similar to the original tetrahedron or the original trigonal planar. We want to know to what extent they will be similar, and will they be larger or will they be smaller? Well, the effect of double bonds, for example, is that double bonds, because they're closer to the central atom, they will have an effect as if they were a bulkier substituent. This means that because this structure, the formaldehyde structure, ideally it would be 120 because it comes from the trigonal planar. However, because of the double bond in here, it makes some effect that pushes down, if you will, the other surrounding atoms. This is why the angle around the double bond will be larger than the ideal 120, and the angle among the surrounding atoms will be smaller than 120. And this is why, for example, if you think of other examples coming from the tetrahedron, you will see that the angles are, when you see a double bond, they'll be smaller than the ideal 109. Okay. Very similar effect is the effect of lone pairs. Lone pairs are also very close to the central atom. They act as if they were a bulky substituent, and they repel the other surrounding atoms to make it closer. So for example, the tin chloride would come from the ideal trigonal planar. So ideally this should be 120, but because the lone pairs typically act as a bulky surrounding atoms, this will deform the ideal trigonal planar, so this will be higher than 120. You cannot tell how much, and this will be smaller than 120. Of course, in this case, if you know that this is 95 and these two angles are the same, you can just do a little bit math and figure out, right? Just careful, make sure that you can identify every time you see lone pairs and double bonds, they will squeeze the other surrounding atoms to get to be a little closer to each other.